building helper methods. If you have a contiguous block of something, you should put a helper method on it. Like, for example, is game over? Howdy, folks. Today we're going to be expanding upon our Wordle table definitions, and we're actually going to be writing a little bit of pseudocode for a couple of things. So there's a couple items that we might care about here, and one of those is determining if the user can start a game. Can the user actually start a game? Have they done the maximum games for today? And when the user guesses, okay. And let's see, determine the user start a game. That kind of goes into actually starting a game, maybe ending games, and getting user stats. So those are a couple things that we might want to do. The most complicated of that is probably going to be determining if the user can start a game. So let's do a function. Can start game, and we're going to have a game type. Okay, so this is going to be pseudocode. This is not real code, but like with any pseudocode, you could be able to turn it into an algorithm. So first of all, I need to find games equals get game with type, which we can do because we have that game type ID, right? So let's actually just make this clear that this would be actually the game type ID. Okay. And then basically, we don't really necessarily care if the game is in progress or finished. Though we do possibly care, you know, I forgot actually here. Created that. We do care how long ago that game was created, right? So what I actually want to do here then is maybe I could do two things. I could filter it here, or I could do it in the SQL. It's going to be more efficient to just do it in the SQL, but I'm going to instead just filter it here. Let's get our actual, figure out how long, how many reset seconds we have for the games, right? So that's important. So I need to actually get so now it's our game type. We need to look for games. Okay, so game now. Well, let's just do this. So basically, we want to look back in the past for this. We want to say, okay, let's say it's 2 hours, for instance. We basically want to say, okay, how many games of this type has this user played in the last 2 hours? So we want to look backwards in time. And this time spot is going to be the earliest, the latest possible start time. Start now minus game type dot reset seconds. So what this is assuming, this is basically assuming that it's kind of a rolling cycle. So let's say this game type is like a 24-hour thing, and I can play 3 a day. It's basically every 24 hours from me starting the game that drops off, right? You may actually want to say, well, the user can play 10 games at a time within a specific period. That's a little more complicated, so I'm not doing that right now, but the data almost supports it. For the data to support it, I actually want something on the game type to indicate to me whether or not the system behaves that way or not. Okay, so now game equals games.filter game at cool. So now I've got all my games that were started within my reset seconds period. And so I'm basically just going to return game.length less than game type dot words per day, which I suppose could actually probably should be games per day, right? Not words per, and actually games per, this should be per period. So let's do this. Games per period. Let's rename that because that's just more specific. It's not words, it's games. Could a game have more than one word? Not right now, but we don't want to preclude that being happening in the future. We'd have to do some rewrites for that, but at least the other data shouldn't have a problem with that. And it is per period, not per day, because a period could be less than a day. Cool. That's basically, can we start a game? Okay. This could be a little more efficient, but that's fine for now. Handle guess. Guess word. Okay. Cool. So handle guess is a little complicated here. The things that we're going to have to do, we're going to have to get the game, get the word, figure out what letters match and which are just in the wrong position. Create guess entry, create guess position entries. Yes, that's another. Okay, so let's get the game equals get game ID. So now the thing we got to ask is, okay, is this game over? Has the user made as many guesses as they can? For that, we actually are going to need to get the game type, which is going to be game.game ID, because that tells us how many guesses we can have. Okay, guesses equals get guesses from game. Do we have that ability? Yes, we have the game ID on the guess. Yeah, and the notice thing is, I'm not actually caring if the user made that guess. I need to know if what user made that guess, but for the game itself, I just need to know how many guesses were made. Game ID, okay. If guesses.length is greater than or equal to game type dot guess count, just return error, or actually, yeah, probably throw error. Because honestly, the front end shouldn't have ever let us do this in the first place, because we can't actually make a guess. So there we go. Get the game, get the guesses from the game. If we've made too many guesses, you might notice I'm doing a greater than or equal to here. You're saying, oh, why don't you just do equals? Well, what if accidentally this code screwed up and someone did accidentally insert a guess somewhere, and now there's seven guesses already in a game that can only allow 6. Well, at that point, if I just do equals, well, the guesses.length is not equal to guess count because it's greater than it, and so the user can make infinite guesses, and then the UI will crash, most likely. So you always want to guard, if it's something that is like this, you always want to guard with that greater than, just in case. You don't want to assume your data is bad necessarily, but it's a simple enough check, and it helps you against some actual bad data. So, that's just why. Always assume that the data there might be too much, and then you should handle that case. All right, we get our word. Let's see. Look at our table. Okay, the game has a word ID. Okay, should also actually start starting game, because that's a thing that involves word lists and stuff. Get the word. Okay, so word equals get word ID. No, this is not actually the word text. So I'm actually going to put obj on there, because the word itself is actually part of that object, and this is the row, which could be useful because we might want some data from it. Okay, find out what letters match. Well, for I 0 to word object. Oh, you know what? That's actually an important thing. Is our guess word too long? If guess word.length is greater than or equal to, there's that greater than or equal again, actually just greater, word object.word.length. Oh, error. This is again something the UI should have prevented us from doing. However, if we have any API, we have to assume people can call that API without actually using the UI, so they could do stuff. So you always want to check and make sure any assumptions your front end is making or anything it's preventing, you want to check in the API as well. So now I can do this for loop because I know that guess word and word object are the same length. Notice I'm not actually bothering to check word letter count. I could do that. I could check that. But I already know that word letter count is being used in start game, because that's the place to figure out what words are valid for this actual game. So I'm not actually going to worry about that too much here. Okay, So basically, let's say if word object.word, this actually should be .word, word at I equals guess word at I, it is correct. And I'm actually going to move these up a bit. So what I want to do, let's put this here because I can actually start creating these positions inside the loop. If I don't do that, I'd have to store some information and then create them later, which is totally fine. But, you know, 3 equals create entry. Oh, you know what? I also need to know the user who's making this guess, don't I? That's important. And actually can start game. I need to know that as well because I actually need to be able to get the user ID. Otherwise, it would just be, oh, all games across all users can only be this many games, which is not what I want. With game would type, yeah. I'm going to recall this just to be clear. Okay, so here we're getting guesses from game. Okay, that's fine. That's fine. Create guess entry. I'm going to do user ID because the guess entry, or the user guess, sorry, create guess. Guess. Yeah, just call this guess. It just has the game ID and the user guess, which I'm assuming this function handles both those tables. Okay, and just returns me the guess object. Okay, so now in here, we're actually going to create the guess position entry. We're going to say create guess entry. This is going to be the guess ID, the guess letter, word I, and then the position is also I. And then if it's correct, let's say this is going to be 0. I had this up here, right? There we go. Let's just copy this down here. Also not 100% sure if tiny int is the right thing to do for that. Okay, so this is actually correct. So we're going to give it a 1 for correct. Okay. Now, I'm going to copy this. And this is going to be else if, okay, you know what? Yeah, the reason because I'm basically trying to go through the guess word, but I actually want to go through guess word instead and go through the guess word. So here, it actually doesn't matter. It's just conceptually, it makes a little more sense to me. If guess word I exists in word.word, okay, that is wrong place. So it's still creating a guess entry, just wrong place. Else, it's not in the wrong place. It just doesn't exist at all. And we're going to create guess entry with 0. Okay, there we go. That's handle guess. It's a little complicated. I know. It's a little complicated, but there we have it. And you can see how we're making use of this data over here to do that. Ending game. Okay. Ending game. This actually should be part of handle guess. So I'm going to call this handle ending game ID. And right now, I'm just actually going to call game ID. Now, handle endgame, what is this going to do? This is going to determine if the game is over. Okay, so this is actually going to be very similar to this part here. Okay, let's actually just return the result of this, right? And okay, so if guesses.length. So now that we have this new guess, we're basically just going to return guesses.length. That's just going to return Boolean if game is over. Okay. There could also be something here like, did the user win the game? That could also be kind of useful. But I'm not going to worry about that right now, because that is, I'm going to say, part of user stats. So let's take a look here. Func get user stats, user ID. First of all, we want all the games the user has ever played. In this case, get games for user. Oh my god, what did I do? There we go. ID. Okay, for games. So for each game in the thing, we're gonna be like, okay, is this game correct? Is this game over? Let's actually change this. Is game over? So I can make use of this. Over, and then we're gonna say game data equals over game.id 1. Okay, so let's make another function for that. 1. So this is game 1. You can see I'm kind of jumping around at this point, but the important thing here is I'm building helper methods that I can reuse in other places. This is something you almost always want to do. And actually, you know what? I probably should actually use this here. Can user make guess, right? If is game over, then throw the error. Right? That's actually a much better use of that because now I'm reusing that code. Oopsie. Totally fine. So I'm just putting a bunch of stuff in here. This is already, you can see, a decent amount of code that's happening, but also it's very flexible because it's making use of a lot of these different things. Okay, so is game 1. All right, so how do we know if the game is 1? Well, the game is 1 if the very last guess has all correct. Okay, so let's say here guesses equals get guesses for game ID. Guesses. If 1, I'm using -1 here as a common syntax, which is just to get the last thing on the list. Not every language supports this, but that's the beauty of pseudocode. Okay, guess entries. Guess class ID. So now we have all our guess entries. We're going to loop over them. Entry of guess entries. And then I'm going to say if, okay, entry correct is not equal to 1, false. Why is that? Because if I have any entry that has a 0 or a 2, it means that that final guess that the user made didn't work, right? So now I can come down here and say is game 1 game.id. And you can see now, again, I'm building these helper methods that I can make use of later on. Anytime you have this code, in fact, I might even want like a get stats for game just for this particular thing, right? Okay, so over 1, what else might we want? Let's actually just grab this in here. Guesses, and because I actually want guess count, because maybe they got it on the first try. We want the word. Okay, how do we get the word? The word is from the word. Okay, and the word is from the game. Okay, so let's call word game, word ID. Okay, now we have our word. All games, and then we're going to insert that all games data. This is actually PHP syntax here, which I'm pretty fond of. And all games. Cool. And the nice thing about this is because we created these helper methods, we've got a very simple function here. It's just calling other functions, and that's functional composition. When you're building stuff, I don't get user stats. Yeah, starting game, we can do start game too. But the thing you really want to have here is when you're building your functions, you want to duplicate as little code as possible, and you want a lot of functions that look like this. It's very clear what this function does. It gets some games, it loops over them, gets guesses, get word, is it over, is it 1? This is not complicated. It doesn't cause a lot of cognitive load to think about it. And that's really important because cognitive load, well, it slows you down. Same thing with here is game 1. I know exactly what I'm trying to do here. Okay, get guesses, get guess entries. This I might have to think a little bit about, but because there's not a lot else going on in this function, I can think about that very easily. Same with is game over. Okay, we get the game, we get the type, we get the guesses, and then we check that. each function is a very self-contained little thing, and this is how you want to structure your code. There's a couple reasons for that. One, because it's easier for you to read. It's easy to snap things together like building blocks, but also AI can generate smaller functions much more easily than larger ones. So if you are splitting your functions up this way, you could just ask the AI, hey, go ahead and generate this function, and it should be able to do it much more easily without hallucination. Okay, start game, game type ID, user ID. So first thing we got to do, how many games has this user played? So I'm actually going to go ahead and, oh, I already have can start game. Cool, I already did this. So if not can start, see, all that work. I just need to call this now. User ID, throw error. And in this case, the error might be an expected error. Sometimes throwing an error isn't always a bad thing. The UI may handle this and say, hey, you've already played enough games of this. But cool, we know we can start a game. Our next thing is find the next word. Okay, so we have a word list ID. Type equals get type game type ID. Okay, so word list equals, well, you know what, actually, I don't really need the actual word list. I'm more interested in the words in the word list, right? But also I'm interested in what was the last game the user played of this. Equals get, I actually need to look this up. There it is, games. Okay. So last game equals games of -1. Well, that's the thing is too, we might not have a last game. Null if game.length is about 0. Okay. So then, okay, last position. I'm just gonna use a trinary here, but basically, oh, this is actually, you know what? I'm gonna call this last word because equals last game get word last game dot word. That's what I want. Because I actually want the word because the word has the position on it. Word is going to be dot position or 0. So basically we start at 0. So what we want to do is we want to say next word equals get word at position word, this is game type word list ID, okay, and then I actually want to increment my position. It's 1. If not next word, throw error. We throw an error because maybe we've gotten through the end of the list. Maybe we're done. But assuming we do have a next word, that actually gives us that whole thing. So now we can actually insert the game. Equals create game, okay, game type ID, and our next word ID, and our user ID. And that presumably is also going to make use of the user game with a role of 0 because that's the owner because they created the game. Cool. Now we can return game.id. So that was a lot that I went through, and I went through it really quickly. But the big takeaway I want you to have here is, one, you can see how I've used this data, and I actually haven't used a lot of these either. Like word letter count. I should probably use that in create game, but I'm just not dealing with it right now. I'm just putting it in the system and not making use of it. The thing about that is first you have your data that informs this, and this is slightly more complicated than it would have been if I was just assuming that the user could only have 1 game a day, or there's only 5 guesses, etc., right? But this means that I have a variety of different types of games I can start, and that's very powerful. Also, building helper methods. If you have a contiguous block of something, you should put a helper method on it. Like, for example, is game over. This is code. It's not that much code, right? It's 4 lines of code, not including comments. I probably could make this even smaller. But it's a logical block of stuff that should be its own function. And that way, and it does get hard eventually to maintain these functions and figure out where they are. So you build things into classes. We'll talk about that later. But the idea basically is that when you're building your code, split it into as many small pieces as possible that you can reuse. And that makes it much easier to build your code and make it so that you're not having to duplicate a bunch of stuff. Anyway, I know it's a little long. I appreciate you all going through it, but I hope it was interesting. I'll see you all next time.